Hello class, this is a continuation of polynomials. In this video we'll be looking at the factor theorem. Continuing from the remainder theorem, we can see that in the remainder theorem it states that if some polynomial p of x is divided by x minus a, then the remainder is p of a. Continuing from that, if the polynomial is divided by x minus a, and if we substitute a into the function and we get a remainder of 0, then we can say that x minus a is a factor. Conversely, or the other way around, it's if x minus a is a factor, if we substitute a into the polynomial, then we should get a remainder of 0, or a function value of 0. Combining this with polynomial division, take a look. We already know this one here, multiplying by a. And here we normally have some sort of remainder. But if our divisor, a of x, is x minus a, and if our remainder is 0, then the original polynomial can be written as the factor x minus a times another polynomial. I'll demonstrate you this in an example here. Let's show that x minus a is a factor of this expression. You can do this in one of two ways. You can do long division, or you can substitute the value of 1, because remember it's x minus a. In this case a is 1, so let's actually do that first. So if x minus 1 is a factor of this polynomial, that means if we substitute 1, so 1 cubed minus 7, 1 squared plus 8 times 1 minus 2, if we evaluate this, we should get 0. So that means, we've shown that it is a factor, so we can say that p of 1 is 0, therefore x minus 1 is a factor. But for part B, if we want to factorize this expression, we can now use the factor to divide this expression. So we know what the value of a is. I'm going to be doing a synthetic long division. Taking now the coefficients, 1, negative 7, 8, negative 2. And remember the procedure for synthetic long division, ignoring the first, multiplying, adding together, multiplying, adding together. That should be positive 2, multiplying, and the remainder of 0. And now, as before, since this is to the power of 3, our division will have one less degree. So x squared minus 6x plus 2 plus 0 over x minus 1. But we don't need to write that because 0 divided by anything is 0. So to write this in factored form, part B, from our long division, we can see that the remainder is 0. We can write p of x can be equal to the factor that we have times the quotient that we had from this long division. So x squared minus 6x plus 2. And that there is our factored form. If we could have factored this even further, we could have written this something like the following: x minus alpha and x minus beta. But for now I can't seem to think of any numbers that multiply to 2 add to -6. So this here is the fully factored form of this polynomial. I'll see you in the next video where we're going to take this in full circle and answer our original question of how to factorize any polynomial of any degree. So I'll see you in the next video. Best of luck.